Mars and Its Canals by Percival Lowell, Chapter 14. Summary. If now we review with the mind's eye the several features of Mars which we have surveyed with the bodily one, we shall be surprised to find to what they commit us. Suggestive as each is considered by itself, the ensemble into which they combine proves of multiplicate force in its implication. For each turns out to fit into place in one consistent whole, a scheme of things in which are present all the conditions necessary to the existence and continuance of those processes which constitute what we call life. In short, we are conducted with a cogency which grows as we consider it to the conclusion that Mars is habitable. Two ways of appreciating this cogency are open to us. We may treat it with the simple reasoning of common sense, as we should a dissected map or a piece of machinery in which we realize we are right when the several parts at last fit together and the picture stands revealed or the machine works. Or we may subject the evidence to quantitative estimates for and against by the doctrine of probabilities, and thus evaluate the chances of its being correct. Consciously or unconsciously, this is what we are about in our decisions every day of our lives. At the one end of the line are those skillful judgments where the balance is so keen-edged that the least overweight on one side dips the scales to a conclusion. At the other extremity stand those deductions which we usually speak of as proved, such as the law of gravitation. But both assurances rest really upon probability and differ only in degree. What we mean by proof of anything is that a supposition advanced to account for it explains all the facts and is not opposed to any of them, and that the balance of probability, in consequence, is very largely in its favor. Now, if several pieces of evidence, distinct in their origin, concur to a given conclusion, the probability that that conclusion is correct is far greater than what results from each alone, and mounts up soon to something much exceeding what bettors at races call certainty odds. However unversed the average man may be in calculating the probability, he recognizes the fact in his dealings with his fellows by the way he attaches weight to concurrent testimony. It is such concurrent evidence that we have now to consider. To this end, we will marshal the several facts ascertained in a summarized list for their easier intercomparison. These facts are: 1. Mars turns on its axis in 24 hours, 37 minutes, 22.65 seconds with reference to the stars, and in 24 hours, 39 minutes, 35.0 seconds as a mean with regard to the Sun. Its day, therefore, is only about 40 minutes longer than ours. 2. Its axis is tilted to the plane of its orbit by about 23 degrees 59 minutes, most recent determination, 1905. This gives the planet seasons almost the counterpart of our own in character, but in length nearly double ours. For 3. Its year consists of 687 of our days, 669 of its own. 4. Polar caps are plainly visible which melt in the Martian summer to form again in the Martian winter, thus implying the presence of a substance deposited by cold. 5. As the polar caps melt, they are bordered by a blue belt, which retreats with them. This excludes the possibility of their being formed of carbon dioxide and shows that of all the substances we know, the material composing them must be water. 6. In the case of the southern cap, the blue belt has widenings in its places. These occur where the blue-green areas bordering upon the polar cap are the largest. 7. The extensive shrinkage of the polar snows shows their quantity to be inconsiderable and points to scanty deposition due to dearth of water. 8. The melting takes place locally after the same general order and method, Martian year after year, both in the South Cap 9 and in the North one. This is evidenced by the recurrence of rifts in the same places annually in each. The water thus let loose can therefore be locally counted on. 10. That the South Polar Cap is given to greater extremes than the North one implies again, in view of the eccentricity of the orbit and the tilt of the axis, that deposition in both caps is light. 11. The polar seas at the edges of the caps being temporary affairs, the water from them must be fresh. 12. The melting of the caps on the one hand and their reforming on the other affirm the presence of water vapor in the Martian atmosphere, of whatever else that air consists. 13. Since water vapor is present, of which the molecular weight is 18, it follows from the kinetic theory of gases that nitrogen, oxygen, and carbonic acid of molecular weights 28, 32, and 38 respectively are probably there too, owing to being heavier. 14. The limelight bears testimony to this atmosphere. 15. The planet's low albedo points to a density for the atmosphere very much less than our own. 16. The apparent evidence of twilight goes to confirm this. 17. Permanent markings show upon the disk, proving that the surface itself is visible. 18. Outside of the polar cap, the disk is divided into red ochre and blue-green regions. The red ochre stretches have the same appearance as our deserts seen from afar. 19. And behave as such, being but little affected by change. 20. The blue-green areas were once thought to be seas, but they cannot be such because they change in tint according to the Martian season, and the area and amount of the lightening is not offset at the time by corresponding darkening elsewhere. 21. Nor by any augmentation of the other polar cap or precipitation into cloud. It cannot therefore be due to shift of substance. 22. Therefore, they are all seamed by lines and spots darker than themselves, which are permanent in place, so that there can be no bodies of water on the planet. 23. On the other hand, their color, blue-green, is that of vegetation. This regularly fades out, as vegetation would, to ochre for the most part, but in places changes to a chocolate brown. 24. The change that comes over them is seasonal in period, as that of vegetation would be. 25. Each hemisphere undergoes this metamorphosis in turn. 26. That it is recurrent is again proof positive of an atmosphere. 27. The changes are metabolic, since those in one direction are later reversed to restoration of the original status. Anabolic as well as catabolic processes thus go on there. That is, growth as well as decay takes place. This proves them of vegetal origin. 28. The existence of vegetation shows that carbonic acid, oxygen, and undoubtedly nitrogen are present in the Martian atmosphere, since plants give out oxygen and take in carbonic acid. 29. The changes in the dark areas follow upon the melting of the polar caps, not occurring until after that melting is underway. 30. And not immediately then, but only after the lapse of a certain time. 31. Though not seized now from their Look, the dark areas suggest old sea bottoms, and when on the Terminator appear as depressions, whether because really at a lower level or because of less illumination, is not certain. 32. That they are now the parts of the planet that support vegetation hints the same past office, as water would naturally drain into them. That such a metamorphosis should occur with planetary aging is in keeping with the kinetic theory of gases. 33. Terminator observations prove conclusively that there are no mountains on Mars, but that the surface is surprisingly flat. 34. But they do reveal clouds which are usually rare and are often, if not always, dust storms. 35. White spots are occasionally visible, lasting unchanged for weeks, in the tropic and temperate regions, showing that the climate is apparently cold. 36. But at the same time proving that most of the surface has a temperature above the freezing point. 37. In winter, the temperate zones are more or less covered by a whitish veil, which may be hoarfrost or may be cloud. 38. A spring haze surrounds the North Polar Cap during the weeks that follow its most extensive melting. 39. Otherwise, the Martian sky is perfectly clear, like that of a dry and desert land. The way in which these 39 articles fit into one another to a mortised whole is striking enough at first sight, but becomes more and more impressive the more one considers it. For some are due to one kind of observation, some to another. In the taking, they are unrelated, yet in the result, they agree. Equally pregnant is the history of their acquisition. Most of them were detected as the outcome of observations of the opposition of 1894 and led to the theory which was published in the writer's first book on the subject. Others are the result of the 5 oppositions that have since occurred. These have proved entirely corroborative of the previous ones and of the theory then deduced, and that in 2 distinct ways. First, by the accumulated evidence they have brought to the matter along the old lines, and secondly, by what they have revealed in new directions. Of these 39 articles of Martian scientific faith in observation or deduction, 9, 10, 21, 22, 25, 27, 28, 30, 33, 35, 36, and 38 are in whole or part new. That continued scrutiny is thus corroborative of the earlier results, both along the old and along new lines of investigation, warrants additional confidence in the conclusion. Considering now these counts, we see that they are reasonably evident on Mars the presence of 1. Days and seasons substantially like our own. 2. An atmosphere containing water vapor, carbonic acid, and oxygen. 3. Water in great scarcity. 4. A temperature colder than ours, but above the Fahrenheit freezing point, except in winter and in the extreme polar regions. 5. Vegetation. First and foremost of these is air. In order to make it possible for vital processes of any sort to take place, the body of a planet must be clothed with an atmosphere. By the modesty of nature, the old astronomers would have said. Such a covering subserves 2 purposes. It keeps out the cold of space, thus permitting the maintenance of a temperature sufficient to support life, and it affords a medium through which metabolism can go on. Now, the presence of air is attested first and foremost by the fact of change in the Martian markings. 12, 13, 26, 28, and 35. The changes observed are conspicuous, are both inorganic in the case of the polar caps 12, 13, and 35, and metabolic or organic 26 and 28 in the case of the blue-green areas. That is, they consist of building up as well as of pulling down and are planet-wide in occurrence. Such changes could not occur in the absence of an atmosphere. They show that this atmosphere consists of water vapor 5, carbonic acid and oxygen 28. The limelight, the apparent evidence of a twilight arc, and the planet's low albedo indicate that this atmosphere is thin. The appearance of the surface, 35, suggests cold, indicative again of a thin air. Such tenuity is in accord with what a priori principles would lead us to expect, and tends to show that reliance on general principles is here not misplaced, a point of some interest. Lastly, the occurrence of clouds, 34, visibly floating and traveling over the surface, and haze at times, 38, proves in another way the existence of the medium in which alone this could be possible. Water is the next substance vital to planetary life. As to its actual presence, the polar caps 4 through 12 have most to say. As to its relative absence, the rest of the disk, 17 through 22. The forthright conception of the polar caps as composed of snow and ice is borne out by further investigation into what could cause the observed phenomena. Carbonic acid, the only other substance we know capable in any way of resembling what we see, turns out not capable of producing one important detail of the cap's appearance, the blue band, 5, which accompanies them in their retreat. Water alone could do this. The melting of the caps shows that water vapor must be a constituent of the Martian atmosphere. Moreover, as the molecular weight of the water vapor is less than that of oxygen or nitrogen or carbon dioxide, if the former can exist in the atmosphere of the planet a fortiori, must these other gases. So that from this we have knowledge of the possibility of the presence of oxygen, nitrogen, and carbon dioxide there. From 28, we saw that their actual existence is demonstrated. The next step is the ascertainment that the water is in very small amount. The extensive melting of the caps, 7, shows that their quantity to be inconsiderable, which is the first fact pointing to a dearth of water. The second comes from the aspect and behavior of the reddish ochre regions, which proclaim them deserts, 18 and 19. The third from the detection of the character of the blue-green areas as not seas, 20, 21, 22. In several different ways, study of these regions asserts their non-aquatic constitution. The easiest to appreciate being that they are traversed by permanent dark lines and other equally sedentary markings, 22. No bodies of water, therefore, are to be seen outside the ephemeral polar seas, immediately surrounding the caps as they melt. This leads us to the third presence on Mars indicative of a living world, vegetation. The other two spoke of substances necessary to life, the premises in the case. This one of organic existence itself, its conclusion. The evidence consists of static testimony from the look of the blue-green areas, 23, and of kinematic derived from their behavior, 24, 25, 26, and 27. Vegetation would present exactly the appearance shown by them, and nothing that we know of but vegetation could. But, suggestive as their appearance is, it is as nothing compared with the cogent telltale character of their behavior. The seasonal change that sweeps over them is metabolic, constructive as well as destructive, that is, and proclaims an organic constitution for them such as only vegetation could produce. In tint, their metamorphoses are those of the same substance, for the blue-green lapses into ochre and revives again to blue-green, just as vegetation does on our own Earth at the proper season of the year, taking both the sun and the advent of water into reckoning. Furthermore, certain of the large dark areas turn to a chocolate brown at times, which is the color of fallow ground and suggestive at least, as occurring where the blue-green at other seasons is the most pronounced. Lastly, the change occurs at the epoch at which, from a knowledge of the melting of the polar caps, theory demonstrates that it ought to take place as if it be due to the action of vegetation. That this was the case was evident from much less information than is forthcoming today. But what is significant, each new fact discovered about the planet goes to show that it is unquestionably true. End of section 15. Recording by Edward Montes, Las Cruces, New Mexico.